Okay, and away we go. We are back tonight for another episode of DanDoesData, and I was gonna switch on to a new topic, but then I decided that's silly. I'm gonna press on with these recurrent neural networks in Keras that I've been horribly failing at, but I had some time to fight with them a little bit on my own. They are now working reasonably well. I think I understand just the stupid data input problem that I was having. Let me just double check that the stream itself is working. Never seems like it is. Okay. We are live. We're good to go. Okay. My mistake about that. Yes, we're continuing with recurrent neural networks. This will, I promise, sort of promise, be the last one on recurrent neural networks in Keras again. And, because it's the third video in a series, probably not as popular, but that's okay. So, you might recall, we had this data set, okay, called train, which is full of way too much stuff. There's a bunch of sequences of integers, and these integers are just stand-ins for words. Using this index to words business, you can figure out what word you're talking about. In fact, let's show you. There are words from airlines that people have put in some query. I want to fly from Boston at digit AM and arrive in Denver at digit in the morning. And the goal is to classify each word into some broad category. And I think it's usually things like from city, destination city, time, like arrival time or departure time, arrival time, maybe even fly. There's 128 classes of things that we want to define. And so the way that we do this is by defining a context window. Whoa. A context window around each word. So let me just show you. So you take a 5-long window, the word you want is at the center, and it's surrounded by these words. And those are your features that you're going to put into a model. And based on this word surrounded by these words, I think this is this class. And you can do that for just a plain old model, and that's okay. But because these sequences all come in this nice order for a given sentence, it actually makes sense to keep some information around from the previous window or even further back maybe. And so that's where the recurrent part of this network comes in. The first one sort of just gets to know, okay, you've got -1, which means no word there, just padding, starting with this. But the next one, it's going to get to see some of the interior values of the previous time sample. And so the problem I was having, let's see, let me just briefly describe the model. There's two problems I was having. We got this model add embedding business. So you've got these sequences, you want to pass those in, but you don't want to pass in just these arbitrary integers. And you could do them all in a wacky one-hot format, for example. But that's not going to be too obvious what's going on then. Or sorry, that's going to take up a lot of space. It's going to be confusing. That might not be the ideal representation. There might be some words that are very similar to each other, and all words are sort of the same distance from each other in one hot. That is, the difference from one word to another is to turn a 1 into a 0 and turn a 0 into a 1 somewhere else. Sort of a distance of 2. What we use is this embedding thing. And what that does is it takes our input 5-long short sequence here, short window, and it embeds that in some vector space. And in our case, the vector space is going to be 1024 long, I think. I think that's right. Or maybe it does that to each word. I'm not even sure anymore. I'm not even sure anymore. Let's look at embedding, actually. This does work now. Turns positive integers, indices, into dense vectors of fixed size. 4, 20 is 0.25, 1, and 0.6, negative 0.2. So that's input length 10, the largest, so yeah, here we go. Embedding 1000, the largest integer, word index, in the input should be no larger. Alright, so each one of these words, the either padding word or the I or want or to, gets put into some strange new vector space. Let's go back to that actually. So here the 4 is getting mapped to 0.25, 0.1, and the 20 is getting mapped to 0.6, negative 0.2. I believe that's correct. Positive integers, indices, into dense vectors, yes. So here they're using a too long vector space in who knows how big, this thing's probably at least 21 different things. And it's a vector space of floats, right? So you do that, and you're gonna, first question to ask is, well, what the heck embedding do I use then? How do I determine that? And the answer is, that's something that gets set by the model. So you don't worry about that. And so the first thing is just, how many different words do I have that I need to embed? So we've got length of index to words. This is a dictionary that takes us from whatever this is, this number, to some word, plus 1 for the padding word. How big a space do we want to embed it in? That's 1024. So each word is going to become a 1024 long thing, which is fine. And this input length is what was tripping me up for the longest time. You'll notice now I have W. I originally had longest. And longest is, the variable longest, is the number of words I have in my longest sentence. And so that's like 46, I think. Yeah. But what they really want in embedding is what's the longest window that you have. And of course, the answer to what's the longest window I have is 5. Because all the windows are 5 long. And this will become more important later when I go to input data for training. Because it is not obvious. Anyway, you do this embedding. And so for a given sample, one pass, let me rephrase this. For a given data point is just one 5 long window plus whatever garbage you get from the previous RNN, the previous time step. So this gets pumped into the simple RNN and outputs 32 things. So there's sort of 32 neurons on this. And simple RNN is just a simple recurrent neural network. There's nothing fancy like the long short-term memory guys. Maybe we'll fiddle around with this and do that later, but we just get information from the previous time step and the current time step. And we activate. Oh, I don't need that activation, do I? Model.summary. I think we're okay. This says it has a default activation now. That's interesting. That is interesting. Tell you what, let's take out this sigmoid part. I don't think I need that. I think it's part of the simple RNN / maybe hyperbolic tangent is more standard to use. Does dense have a standard? Yeah, dense's standard activation is linear. So in other words, don't do anything fancy. Don't do anything that can't be undone in another layer. Anyway, so you got simple RNN, and then we just had the output and labels. And labels is, I believe, 128. Yes. There are 127 classes plus like some miscellaneous class. And use the standard softmax to figure that out. And because we're using the new Keras, we're just doing SGD as SGG, stochastic gradient descent. And the model, we say it's categorical cross entropy because it's a classification problem, and our optimizer is just the SGD object. There we go, and you notice it compiles blazingly fast because in the new Keras it doesn't actually compile until you go to fit. So here's what happens. Train W is my actual data. So train W0 is the first sentence, but the catch is you want to pass in each data point in this model is actually one window. So if you want to batch stuff up or do a bunch of things, you pass in one sentence at a time. So if I try to pass in this, it should yell at me. It'll take a little bit to compile first, but doing train W is not going to work. It's going to talk about a size mismatch, and it's going to talk about, oh, you passed me a list of a whole bunch of arrays. Yeah. Error checking model target. List of numpy arrays you're passing your model does not match the size of the model. I expected to see one array, but I got 4,978 arrays. And guess what? Length of train W is 4,978. Big surprise. So that's not what you do. You need to pass in one sentence at a time. So for example, you want to pass in train W0. You want to pass in train W properly typed 0 at a time. If you do that, then you can get the right answer. Then you can actually train. It trains a sentence at a time. You want to train on the other sentences, you got to pass in the other sentences in a separate call. I haven't figured out a good way to do all those things yet. Maybe there's a way to fiddle with this model or model shape to do that. So I've got a kind of poor man's rig here. Oh, fucking come on. Inconsistent tabs. Baloney. Baloney. Use of tabs and spaces and indentation. That is not true at all. Actually. Maybe it's that. That's the problem, maybe. This is baloney. That's not supposed to be a problem in this version of Python anymore. Alright, let's see if I've got... That goes there. That's my TQDM. My enumerate goes there. No, I don't think that's actually a problem. I think it's just full of shit. Model.fit. Yeah. No. This is full of lies. Full of lies. Alright, what if I just try to do... It's like it's using Python 2 or some old version of Python. That's really annoying. There we go, now it goes. I thought I turned verbose to 0 though. Hang on. Verbose equals 0. There we go. Okay, so this is TQDM going. That is taking a shockingly long time. It's going to take 5 minutes to run. Stream does not have time to wait 5 minutes. So we're going to be cutting that short after just a few hundred sentences there. But you'll notice this model's actually running unlike any previous models I've run with this. So what are we doing here? I wanted to run for 10 epochs, but that's apparently not going to happen. Let's comment that out. I'm taking... Why am I even taking I? Whatever. Yeah, there's really no reason to do that. I just got a progress bar, that's TQDM, and I'm iterating through pairs of train W and train hot, where train hot is my one hot labels for what those center words actually are. And I'm passing in total length just so I can get a progress bar, because I'm using the enumerate object. That enumerate is an iterator, but it doesn't have a length, so TQDM doesn't know how to handle that. It just says, I don't know how close to done you are, because I don't know how many there's supposed to be. But if you say total, then it knows how many there's supposed to be, and life is good. And so we're just pulling TR and hot out of there, and we're doing the model fit. I'm saying batch size 1 because I'm not sure how the batch size is going to affect things in this kind of model. Because this is one sentence here that I'm passing through at once, it sort of has to start at the beginning and continue on through. I've fiddled with saying bigger batch size and passing in a bunch of data at once, but that doesn't seem to work. And because I want to train through all of the data first and then pass through it again, that's why number epochs is 1 here. And verbose 0 because I could try verbose 1, but that's going to screw up my progress bar here. So that's not what I want. Wonder if I can fiddle with the progress bar. Oh, I see now. Anytime it updates. Oh well. Okay. Where are we? So, let me kill that. It's dead. No more. H.history. But we got something. We got the final loss function. We don't have we don't have accuracy because I didn't pass in test data. I have test data. Do I have metrics? So we can do model.predict. Is that what I want? Generates output predictions for input samples, processing the samples in a batched way. Yeah, let's model.predict. What's our input here? So you have to say like test 0, for example. Test W0. It's a window. Yeah, and that gives you information on the classes. But I want model.predict classes. There we go. Test W0. Let's try that. Yeah, so now you can see the actual classes in the final sentence. And you could say test hot 0 to see the, no, that's not what we want. Test 0. Jesus. No, test, oh God. It's not test hot, it's test. Oh boy, oh boy, oh boy. Test 2. 0. Right, because of the strange way in which these are stored. Nope. There we go. Okay. And you can see the model is doing a very good job of getting these 126s. Gets whatever this 48 is. I don't recall what the actual classes are, of course. Really good at 126s, which are like other words. So that's just a good like default. And then 71 and 78 it mixes up. I don't know if these classes are actually related. I would hope they are. So that's an interesting thing. What is the actual model.predict classes? Yeah. Classes TW. That gives me array. And I just want to minus test2 0. And can I count things in an array? No, I don't want any count. I want a of a greater than 0. Just ask for the length of that, and that's it. That's one way to do this. So I'm trying to get a poor man's accuracy because Keras is giving me trouble with the RNN model and getting an accuracy out of it. I wasn't happy about that. So we're going to subtract not TW, T hot for the, no, not T hot for labels, just T. T for the actual yeah, okay. For TW kind of T, oh right, and I want, oh jeez, I gotta make that array, and is there numpy dot like zeros? No, I want to count zeros like, I want to count something in the array. I want to know how many non-zero entries there are. Numpy dot non-zero? Oh, hang on. Return the indices of the elements that are non-zero. Actually, that would be fine. A dot non-zero. A dot non-zero. Perfect. Oh, God. Why? You torment me. numpy.non0 of this. And so we want the 0th one of that, and we're going to call the length on it. Whew. So that's going to count how many times we get something wrong. For t, comma tw in zip test w, comma test2. There we go. Ers. And I only care about overall counts, so let me just say numpy.sum of this. There we go. Why? I don't understand why they torment me there. Error is 1809. And if I want to know the length of everything, num words equals this thing, test2. Let's say numpy.sum of map of length test2. That sounds right to me. So how wrong are we? List of that, of course. There we go. So we're getting about 81% accuracy, given that we're at about 19% error. That's actually not that bad. That's, granted, how much of that is just 126s that we're getting correct? You know, you can judge that for yourself. That's probably where most of the accuracy is coming from. This 80% business. That's interesting. But that's what you get for having a lot of words that are garbage in your sentence. But we saw that it was legitimately doing something else. Test W, not test. Yeah, test. Yeah, no. Oh boy. Test2 0. Right. Versus. Yeah, it was legitimately getting some things correct. These things, and it screwed up here and here. So you know, not the best. Look at the last guy. There's an awful lot of 126s here. This one happened to get perfect, which is interesting. Okay. So again, the catch is that we only put in one sentence at a time into our model. So just tr and just whatever our current labels are of these windows. That's what threw me for a loop. I thought I could pass in all the data and it would run through each of those sequences on its own, but that is not the case. So, and the way to think about it is each window is just a bunch of features that you're putting into the data. So there's sort of 5 features that you get to see, plus whatever the stuff comes from the recurrence. So another, I'm not 100% sure what it gets to see there. You know what? Let me say model.get weights. Yeah. What does that give me? How many things do I got here? 6. Interesting. Because there's 32. Alright, hang on. Model.summary. What are the 6 weights? Simple RNN, activation, dense. Oh, it's the embedding. That's what it is, the embedding. Right, because it's got to figure out the appropriate embedding to put the words in so they make sense. So words that are sort of similar, hopefully have similar embeddings. So what is A of 0? Dot shape. What is that? 573, 1024. So 573 is how many input words I have. So this is for the embedding. Yeah, so if you get a word like this, it goes into this this 1024 long embedding. That's all that is. So for example, whatever word is index 0 gets this wacky. You know what, let's just plot this stupid thing. I believe I have plot dot color mesh A0 in fact. There we go. This looks like garbage to me. There's some interesting things in here. Like, what's this line? Why is this so special? Like, most of these look... Oh, that was really helpful. Did that wrong. Wanted to zoom in, not out. Important differences. So there's a couple lines that look different. Is that just artifacts? No, they are legitimately different. I don't think I actually want 1024 things, though. I could probably get away with a smaller model, huh? What's A of 1? A of 1 is what takes our embedding and pumps it into the simple RNN. So that's 1024 input things, 32 output things. I'm betting that the next one is going to be 32, 32, stuff from the output of the previous models, previous time samples RNN, going into RNN. The current time samples RNN. Just a guess. All right, let's see what happens. Bam, 32, 32. So this says, take whatever the output of the RNN from the previous time sample was, hit it with these weights, and that becomes an output of the current time sample too. So if I say model.summary, should see... Alright, well, whatever. Alright, but that was A2. So let me just plot that for giggles. It's not a great model, but it does something. So I'm not sure which ones are the inputs, which ones are the outputs, of course. But different guys are working differently. And it's not just like a diagonal. That's true. That's the interesting thing. It's not just a diagonal. It's not just, hey, here's more of the same. It's not just shifted by a little bit. They are being used differently. What is A3 then? 32 comma nothing. 32 bias terms for our simple RNN. A4 is going to be 32 bias terms from the previous time step. No, it's not. Oh, this is output. So this is 32 inputs from our simple RNN going to the output. Is 5 then the same thing? 128 comma star comma nothing. So just 128 values? Oh, these are 128 biases. Derp. And this is... So what's curious to me is that A2.shape... Oh, right. These 32 inputs, which I believe are the outputs of the previous time steps, simple RNN layer, go into this simple RNN layer in the next time step. So each one of these goes into every single one of the neurons here. That's why it's 32 by 32. So you still have 32 outputs at this point going into dense labels, and hence 32, 128. And you have 32 bias terms. And 128 bias terms for which class are you in. Alright. I feel like I understood something now. That's very dangerous. So I didn't see a good tutorial on how the heck to do this on the internet, so I'm glad that we were able to get this to work. Again, this, let me just show you guys. Deep learning. This was from a Theano tutorial, believe it or not. If I want to search, I want to search for RNN example. Is that what I wanted? That's not what I wanted. Alright. Theano RNN example. See if I can dig that up. RNN SLU, yes. Learn word embeddings using recurrent neural networks and with context windows. So if you go to this page, deep learning.net tutorial rnnslu.html. You can see where I stole the data from and stuff like that. And so that took a little bit of time to fight around with, but we got it working eventually. And I'm sure if I let it run for a much longer time, it would do better. Now that we have a working model, so there's simple RNNs. But there's also these things called LSTMs, which are long short-term memory. And so the RNN says, hey, take the output of whatever the previous time step was and put that into this layer. LSTM says, hey, take whatever the internal cell state was, and I'll define that in a second, and use that to update the current neurons, and decide whether we want to update the cell state or not. So you can sort of remember things from a long time ago if your model deems that those are important to remember. Let's try the stupidest thing. Let's just try to remake the entire model and just change one line. This is mind-blowing that that actually does something. That's taking a long time. No, holy moly. Oh gosh. Oh, I can't wait that long. That's taking too long. I don't have that much patience. All right, this doesn't need to be 1024 long. This needs to be like 128. Let's try 256. Let's try 16 of these. Make a smaller model. It's a little easier on the old GPU. Okay, come on, come on. Oh boy. Oh, it's got to compile too. Right, I forget about that. That's probably what the delay here is. I liked it much more when Keras compiled on the actual compile line. This is troubling. Troubling that I'm getting nowhere. I'm not finishing even one iteration here. Alright, that's ridiculous. TR? TR. We're still on 0? Why? Why are we still on 0? What if I'm verbose? Is there a crap ton of data? Am I using LSTMs wrong? I'd love to know that. Refreshing lock, so it's compiling. Maybe LSTMs take it forever to compile? We're waiting. We're waiting. We're waiting. Losing patience. Alright, well, I'll let that decide if it wants to do anything while I work on something else over here then. The joys of multiplexing in the terminal. So, that data I did eventually figure out, but it's kind of a pain to understand. I would rather just have a data set where I've got like an arbitrary set of distinct features that I don't have to embed, say. There it goes. Okay. Jeez. All right. So it didn't actually take long once it compiled. So let me just try this. There we go. Jeez, don't do that. Okay. There we go. Anyway, so I want just like 5 features or whatever, a small grid of features, who cares? And they're not some word embedding, they're not context windows, they're just 5 distinct features. Like maybe I've got temperature on a given day, and precipitation, and cloudiness, and whatever. And maybe I'm trying to predict, like if you had a regression problem, maybe you're trying to predict the humidity. If you've got a classification problem, maybe you're trying to predict like what season it is. Does this look like winter? Does this look like whatever? And so there's this time component because you've got all the previous readings from the previous days or weeks or whatever. And so you'd want to know that. So that's, to me, I think that'd be a much simpler example. Now whether that actually works, who knows. So you could have a very simple example of, you could input, say, temperature, precipitation, I don't know, wind, wind speed, and our output is season class. So winter, spring, summer, fall. So you've got 4 classes, and maybe here you've got, yeah, sure, whatever, three input variables, and maybe you're taking information every month, every day, every whatever, and you're trying to classify, okay, for this reading, what class am I in? So that would be interesting to me. Actually, I kind of want to get some like real weather data now and sort this out. Let's see if I can whip something up real stupid, like some fake data. So if I say temps of numpy.sine of let's see, numpy.arange 365, and I'll have to futz with that. All right, we're done with this. I'm done training this. Oh, but let's see if that did any better. Train the model, you know, on a handful of things. That does take longer. Well, right now this model's doing worse, but we also cut down the embedding size and we cut down the number of neurons there. All right, let's make some fake temperatures. And I want it to come back around. And I want to take that times 2 times numpy.pi divided by 365. I want it to make 1 cycle in a year, right? We'll deal with these proper temperatures in a second here. If I say plot temps, yes, we've gone through 1 cycle of temperatures. Maybe it's the spring, you get the summer, you get the fall, you get the winter, and back to spring. Sure. And so that's that. Plus numpy.random.rand. 365, is that how that works? Temps. Yeah, okay. But I want +1. So we had some random noise, we had some of that. I'd want not that much random noise. I don't know, maybe 1% variation. And let's set this on, I don't know, 50. What happens then? Plot temps. That is very minimal variation. That's probably want a little more than that. Oh. Alright, we can actually have a lot more variation. Wow. I thought that was going to be terrible. Yeah. Alright, so whatever. That's fine. Well, that gets real hot and real cold. We can actually... I can stand to get colder. Right? Yeah. Say 35. I just want to make some fake data there. Oh yeah, that's totally reasonable if you're in Fahrenheit. Go down to about 0, and you come back up here. That's not real weather data, of course. So if your temperature goes in this nice scale, your precipitation, that's highest in the fall, right? No, in the spring. It's high in the spring and not much else. We'll say lower the rest of the year. So how to handle that? Oh, recips. You know what? Let me just grab daily precipitation. Daily precipitation. Yeah, total. I just want some, you know what, like text file. I'll just read in some actual text file of how much it rained. This is daily precipitation. Units, hundreds of inches. What are these? Oh, this is the day of the month. God, this is terrible. Why would you torment me with your terrible, terrible... Alright, let's get a recent. What is this? T? T's are going here. So many T's. Precipitation data file. Alright, that could be used. Read from WILD, National Weather Service. Data file. US hourly precipitation data. No. That's not what we want. Read from, that's not what we want. Daily Oregon temperatures. That's actually interesting. Daily precipitation. This is going to be the same stupid format, I bet. Oh, gosh. Why? Why do you oh, T's for trace. Right. Alright, what is this PR about, though? Who cares? It no longer matters what TR is about. M is minute, or M is the total? Oh, M is the month wasn't that long. Right. So well, let's just grab this. We're going to use real precipitation data. Rain string. There we go. Oh, jeez. That is, yeah. Rain.txt. I can't stand to have that in there. It's going to drive me insane. Let's kill all that. Okay. Make sure I understand how to parse one of these files. Parse rain. I understand this is probably not super exciting for people anymore. Me trying to generate my own data set, but that's okay. This is just for educational, and I wanted to look at this. That's quite all right. Other things that you may have heard. Oh gosh, I cannot talk and try to concentrate on parsing data at the same time. I'm terrible. S.split of whatever. String.split. What do we get with that? Okay. So skip the first two. Two and go down to the end. 1 PR. Is that 1 April? What does that even mean? PR month. PR. Yeah, it's hundreds of inches. I get that. PR, 11 PR, 12 PR. I mean, it's the first month. PR. Are they all PR? I think they are PR. Alright, well, whatever. Oh, geez, not all of them have. Ugh. Ugh. Alright, so I can't even do that. I have to say S of. Let's see. That's the 0th guy. 1, 2, 3, 4, 5, 6, 7, 8. 8 to the end, I have to do. 8 to the end, there we go. Yes, then we start with T. Perfect. So none of this skipping the first two business. Dot strip. Make sure to get rid of that ending new line. Okay. So we'll say for amount in there. We say if amount equals t. T. This is just to parse a single. Hang on. Yeah. Month rain equals nothing. Yeah, there we go. Month rain dot append a 0. Else append. Yeah, append whatever the value is. Month rain dot append. Dot append and int of amount. And our units are just going to be hundredths of inches. That's about the same. Scales our temperature, so that's fine. I think that's going to be fine. Turn month rain. And so with open rain.txt read as f, and if I say all rain equals this, and I say for month in f, I believe that's how I can do this. Yeah. I say all rain.extend parse rain month. And then I can say precips equals numpy.array all rain. Now is when everyone should yell at me and say, what are you doing? You're missing a key argument. Don't do it. Don't do it. But I'm doing it anyway. Invalid literal base M. Right, of course. Elif amount equals M. Continue. We don't care if the month's not that long. There we go. Oh, there we go. Precips, and if I plot my precips, plot precips, that's interesting. The rain over the course of a year. Let's actually plot precips. I want those as blue circles because they're raindrops. And plot temps. Those must be red X's, of course. There we go. So, and I could mark these with timestamps and plot them that way if I wanted to be really particular. But starting, this must be the start of spring. Let's say this is April 1st right here. You go in, it's kind of rainy, precipitation drops off. In the fall, that'd be here, and starts to pick back up in the winter. So this does have some interesting information that's crazy noisy though. That's alright. What was the matter thing? Wind speed? I don't think wind speed is actually important. We're gonna ditch that. Boom, no more wind speed. Okay. So now I sort of have data for a single year, so to speak. Year, where year is something like something. I want to grab this. Grab my model there. I need labels, right. So our labels are going to be, how much time do we have left? 10 minutes, alright. Cool. Right. So I could just say numpy.zeros of, I want it to be size, how many rows? 365. There are 365 days in this year, right? I didn't pick a leap year. Let me just double check that. I picked not enough time, apparently. How did that happen? What? How did that happen? That's super annoying. That's super. Did I miscount this? Is M just mean they missed it? They didn't have it? Oh, that's February, and there's 3 short, which is 31 minus 3, so that's actually normal. But if there's other M's, maybe those are wrong. Are there places where it filled in the gap? No, there weren't any big outliers. The biggest one was 100 or so. That's weird. That is strange. Okay. Well, I'll tell you what. Here's what we're going to do. We're going to do something terrible. Oh no. Plus 0 phi in range 365 minus length of all range. Since this is just fooling around, who cares, right? That's not right. Yeah. There we go. You can see all our zeros at the end there. In the early spring. Yeah, well, whatever. So it goes. So it goes. No, that's late winter. Late winter. Yeah, it's no longer early spring. It's late winter. You don't have lake effects now. Comma 4. We have 4 classes. Being of 4 seasons. And I'm going to say that labels of not all the rows of the first, gosh, 90? Yeah. Of the first 90 equals numpy dot array all the rows, yes. This is winter, so winter will be the first one. No, spring. Jesus. So I get for starting my year on April 1st. Whatever, that's what it is, what it is. It is what it is, my friend. So from 90 to 180 is, of course, summer. And now 270 and 270 to the end. Winter gets that extra little bit. Let's do that. We have 5 minutes left. Perfect. Perfect. All right, I don't need this stupid betting baloney anymore. Maybe I do. I don't think I need it. I don't want an LSTM. I actually want a simple RNN. No, let's stick with the LSTM. So I don't really want an embedding because I have actual features now. Let me do that. And LSTM. Input length. Is that all I say? Input length equals input length equals 2 because I have 2 features, right? Right. Jeez. Let's say data equals. How do I? Oh, numpy dot concatenate. Each one set the same shade except the default join a sequence arrays along an existing axis. Dot concatenate. And if I say temps, comma, precips, what happens? Only like one of A's can be written in Python. There's temps, precips, temps.shape, precips.shape. Yeah. Function takes at most 2 arguments, 3 given. What? Ah, frigging. I tell ya. What's the shape of that? No, that's not quite right. Axis equals 1. Axis is out of bounds. Axis equals 0? Alright, numpy dot zeros. Let's do this our own way. Comma 2, and data of everything, comma the first column equals temps, and data of everything, comma the second column equals labels. Not labels. Jeez. Recips, right? Believe that's correct. Okay. Let's try to whip up this model. Let's see how this works. I have 4 labels. I don't need to iterate through all these things again, because I only have 1 sentence, 1 year that I'm trying to figure out. So this should just be data. This should just be labels. And I definitely want verbose 1. Now prepare to have this blow up in my face. That did not take long at all. Input shape. Alright, fine. Input shape equals 2. Can I get away with that? Input shape 0 is compatible with LCM. Expected end dimension 3 found 2. Right. None, comma 2. Is that what I want? Actually, let me rebank that. There we go. No. Expected end dimension 3, found end dimension 2. Right, of course. Of course. Oh boy. Tell you what. Let's bring that back there. Let's suppose I did want an embedding. No, I definitely don't want an embedding. That's definitely not true. Not correct. None, comma 2, comma 1. Is that right? None, comma 1, comma 2, whatever. Expected end in 3, found end in 2. Found end in 4. Just can't win sometimes, eh? Alright, that ran. Alright, watch this blow up in my face as I don't have the right things at all. Takes forever to compile, because that's the way LSTM is, yada yada yada. But this is starting to, the crank's starting to turn. Got some information. If you wanted to do a regression problem instead, you could try to encode the season and predict, say, the precipitation or the temperature. Yeah, figures. Expected 3, got 2 with shape 1, 2. Yeah. So, 2, comma 1. There we go. And 0, and 0. What if I can do this? Will this work? There we go. Look at that. Wham! That's pretty cool. Can I show accuracy equals true? Can I do this? Well, yell at me now. Must be passed. Pass to k dot function. That's super annoying that it's. Oh, you're late. Yes, I am 1 minute left. But you'll got to know that it succeeded. Arrgh. Alright, well, screw accuracy. Nobody cares about accuracy, right? So we'll train in 2 epochs then. Normally you need a whole bunch of epochs to get somewhere decent. I'm psyched that this actually is running though. With just a little bit of, I don't know why I had to do the input shape this way. That's frustrating. But it is what it is. So model.predict classes, yeah, data. There we go. So this is totally wrong. If you take a look at the actual labels, for example. Oh, this isn't totally wrong. No. Well, it is wrong. It's saying everything is fall. Just about everything is fall according to this model. Everything else, because most days don't have rain and most of the fall days don't have rain. That is why it is sorting out what it is. Oh well, that's okay. So this time we got our old model working to try to understand these word embeddings and strange airline information, and we got a super simple model running at least of using weather to predict the season, which I think is kind of cool. Let me just start that running right there. Go for 100 epics. See how that does. It's using just temperature and precipitation and with a long short-term memory to try to guess what season are we in, given the current weather and what I know about past history. And of course I'm using fudged temperatures and the rain is a little messed up, but that's okay. None of that really matters. So that's pretty cool. I think this is the last RNN in Keras video I'm going to do, because we determined that the necessary thing is you have to pass in the data as a sentence, and that for the word embeddings you have to worry about the length of the longest window in that sentence. So once we figured that out, this all makes much more sense, and it's much easier to set up a model like that. So next week we will be back with a regular video. I think I'm actually going to be revisiting some TensorFlow stuff by fan request. Someone asked me to go through one of their tutorials line by line. So it's sort of going to be the start to a new series just called Line by Line, where I walk through an existing tutorial, maybe one of my own, or maybe one from TensorFlow, and just explain this line does this. It has changed. You can change it to do this if you change this piece here. If you want to do that, then you need to do other thing. So just very slowly walk through it, because it's so easy to read through their tutorial and get really lost real quick and be like, oh, I don't know what this or that this other thing is doing. So I think that would be helpful. All right. You guys have a very good night. Thanks for those of you who made it out, and I'm glad that this RNF stuff finally worked.